Okay, so today we're gonna go over scientific notation and conversions, and we're gonna do as much as possible. So I'm gonna start with page 31. Okay, so now here we talk about the power of 10. So if you have 10 times 10 times 10 times, well, how many times is this? 5 times. We're gonna use exponential. Yes, I can zoom in a little bit more. Yes, no problem. So you can express that as exponential notation. Okay, that's better, right? Okay, so we have 10, 10, 10. How many times? We're gonna write it with 10 with power 1, 2, 3, 4, 5, because there are 5 of those 10s. Okay, and also you have some more examples here. If I have the number, so any number can be represented with multiplying by 10 with the power. So 2, the easy number 2 is 2 times 10 to the 0. 10 to the 0 is always 1. So 2 times 1 is technically 2. Then you have example 20 is going to be 2 times 10, which is technically 2 times 10 to the first. Then 200 is 2 times 10 times 10, it's 10 square, right? And then 10 cubed. So they give you some example here. So the next one, we need to try how to do 2 millions using the pattern above. So 2 million is going to be 2 times, how many zeros we have? 6 zeros. So we're going to have 6 times multiplying by 10, because each multiplying by each 10 is going to give us a 0. And one more. So we have 2 times all these 6 tenths, and when I rewrite this, it's going to be 2 times with exponent, which is going to be 10 to the power 6. So that's how you do it. And then this is the definition for scientific notation. So we have the scientific notation is if you have a number, it's going to be represented with a number no less than 1 and 1, but less than 10. So the number in front has to be between 1 and 10 and 9. Okay, so here less than 10 means 9. So the number in front has to be less than 10, and then you do it like times 10 and then with exponent. Okay, so the number in front here has to be from 1 to 9. That's what that means. Okay, so all these here notations we have, all these expressions we have given here, these are in scientific notation, and this one also. Okay, because the number in front is 2, which is between 1 and 9, and then you have times 10 with exponent. Okay, everybody understand the definition of scientific notation? So scientific notation is when you have number between 1 and 9 multiplied by 10 with exponent. Okay, so now let's look at this one. We have convert from scientific to decimal notation. So here we have this number 7.3 times 10 to the 4. So when you have times 10 to positive exponent, so if the exponent is positive, you're going to move the decimal to the right 4 places because the exponent is 4. So I'm going to start moving from, so after the 3, so it's going to be before 3, so I'm moving it once, it's going to be 3, 2, 3, 4. So the decimal points move from here 4 places, right? You have 1, 2, 3, 4. Everybody understand that? So my answer technically is 73,000. So this is the decimal notation, which is like getting the number in decimal form. Or so when you're using the scientific notation, the scientific notation is used when you have a huge number or very small number. So if you have like 25 billions, you're going to use scientific notation. because all these zeros, when they become many zeros, it's easier to see them with 10 with exponent, okay? The same way if you have smaller numbers, if you have like 0.0000 many zeros, it's easier to see the number with scientific notation. So it's going to be 10 with exponent negative number, okay? So here you have the examples here with the negative exponent, negative integer exponent, okay? So it's a easy way to represent division of the same number. We did that last time, if you remember, right? So 1 divided by 10 is going to be 10 to the negative 1, negative 2, negative 3. We did that last time, okay? So let's do the next one. We have 1 divided by 1, 2, 3, 4, 5. So it's going to be 10 to the negative 4. Or actually 1, 2, 3, 4, there are 5. I'm sorry, I missed count there. Okay? So if you divide by 3, it's going to be to the negative 3. If you divide by 2, 3, 4, 5 tenths, it's going to be 10 to the negative 5. Okay? Everybody understand that?
Yes, ma'am.
Okay, now the next one we have given when the numbers are rewriting with, when you rewrite the number with scientific notation. So 0.5 is going to be 5 times 10 to the negative 1. So the exponent here, negative 1, gives me how many decimal I have, how many decimal places I have after the decimal. Okay? Negative 2 and negative 3. So now let's convert this to decimal notation. Now, when you multiply by 10 to the negative, you move the decimal to the left. So when you multiply by positive exponent, you move it to the right. When you multiply by 10 with a negative exponent, you move the decimal place to the left. So what that means, I'm going to move it 5 places. So it's going to be 1, 2, 3, 4, 5. So the decimal is going to be here, right? And I'm going to fill out the empty places with zeros. So it's going to be 1, 2, 3, 4 zeros, and then 42. So my answer is going to be 0 point. So the decimal point is here. Then I have 4 zeros, and then 42. Okay, so when you write scientific notation to decimal, you move the decimal to the right, to the left, and or to the right, depends what is the exponent. If the exponent is negative, you move to the left where the negative numbers are. That's how you can remember. And if the exponent is positive, you move to the positive numbers. Okay, and always remember, negative exponent means small number. Positive exponent means huge number. So look at the answer, 0 point, it's a small number, right? It's not 42,000 or something like that. So always when you change it from notation to notation, look at the numbers and see, do they make sense? Okay? Any questions so far?
No, ma'am.
Okay, so here we're gonna do this in groups later, when you have to find different things with different measurements. So this is about conversions now. They give example, 1 meter is the length of a guitar. It's about a meter long, right? While 1 hectometer is the length of a football field. 1 gram is the mass of a paper clip. 1 milligram is less than a grain of sand. And 1 milliliter is 20 drops of water. They give you some examples. 1 square meter, the area covered by a large opened umbrella. Okay, so you can think about examples or look it up online for all these different measurements, so to get a real idea what this actually means. Okay, so we can do that in groups in a minute. Let's just finish the scientific notation here. So we have, let's convert from decimal to scientific notation. So here we have so where I need to put my decimal. So let me show you this. So it's 35,400,000. So because the scientific notation, the number in front has to be between 1 and 9. So I have to put my decimal after 3, right? It have to be 3.54. And then I need to write times 10. Now, is the exponent is going to be positive or negative? What do you think? Is it a big number or small number?
Big number.
Big. So is it going to be positive or negative?
Positive.
Positive. That's right. So now, looking at 3 point something, how many places I'm moving? So what's going to be the exponent?
7.
It's going to be 7. That's right. Everybody see that? So there are going to be 7 places to move from 3 point to 35 millions, right? So that's my answer. Now let's look at number 2. Again, where you're going to put the decimal is going to be after 9 points, right? Because the number has to be smaller than 10. And 9 point something, it's smaller, right? Smaller than 10. So we're going to have 9 point, you're going to keep everything, 876 times 10. Now, positive or negative exponent?
Negative.
Negative, because we have small number. Now, let's see from the decimal point to the point after 9, how many places we're moving. I think I need to make it bigger. So we're moving 1, 2, 3, 4, 5, 6, 7, 8 zeros. So it's going to be 9. Negative 9. Everybody see that? Probably I should make it a little bigger so I can see.
Yes,
So
sir.
I have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's right. Okay. Everybody good with that?
Yes, ma'am.
Okay. Then you're going to go and do number 3. So number 3 and 4, we have to do backwards. So they give me the scientific notation and we have to get the number. It's going to be a big number or small number. So let's see. If it's positive, that means it's going to be a big number. That means you're going to move the decimal to the right. So right now I have 2 places to move. So it's going to be 2, 3, 2. And then I have 4 zeros to fill it out with zeros. Okay, everybody understand that? Because the exponent is 6. So right now you're moving 1, 2, and then the rest of it is going to be with 0. So I need 4 more zeros. So that's going to be, I'm going to put the commas here to be 2,320,000 is the big number here we have. Okay. Then the same way we're going to do the 5.2 times 10 to the negative 3. Now, because it's a negative, you're going to move the exponent to the left. And from here, you're going to move it 3 places. So it's going to be 1, 2, 3. And you're going to fill those. So this is where the decimal is going to be. And you're going to fill this with 2 zeros, right? So my answer is going to be 0.0052. Okay? So these are my answers. Any questions? Okay. So here we have more examples of this. We're going to do that in a minute. Okay, so I'm going to pause and let's talk about that. So here, when you talk about the metrics, the metric units, they are meter, gram, liter. It could be also second. And these are the prefixes. So you have M stands for mega. So you can have megagram, megaliter, megameter. Okay. So these are the prefix M. Capital M is for mega. Lowercase k is for kilo, kilometer, kilogram, kiloliter, right? Kilosecond. You can have that also. Hecto is H, deca is GA, and then you have deci, which are part of 1/10 of the gram, decigram, decimeter, deciliter, okay? Then you have centi, milli, and micro, okay? So also pay attention of the exponents, so or the number of units. The exponent is gonna help you when you change the units. So if I change, so this is like, look at this like a stair. You're going up and down the stairs. And depends how many units you're gonna go. So looking at number 5, the example we have here, number 5, let me make it like this so I can see. So we need to change, we're gonna change centimeter, meter. So that means I'm gonna go from centimeter to meter, right? So we're going how many, like imagine this a little stair. So going 1, 2 steps, right? So if you're going 2 steps to the left, you're moving the decimal to the left. So the decimal is gonna be 1, 2. So it's gonna be 0.5 meter. So 50 centimeters, it's 0.5 meters. Everybody get how we do that?
Yes, ma'am.
So doing the conversions in metrics is really easy. You just move the decimal to the left and to the right. And why are you moving the decimal? Because you're multiplying or dividing by 10, right? So all these exponents, 10, 6, 10, 3, 10, 2, 10, 1, and all these 10 exponents is actually moving the decimal. So if you're going in this little table to the left, you're moving the decimal to the left. If you're going to the right, you're moving the decimal to the right. So that's all. Okay, the next one we have, it's kilogram to gram. Kilo to gram. So we have kilo is here, gram is the base, right? So how many steps? 1, 2, 3 steps, right? So I'm gonna move the decimal is after 8. So I'm gonna put 3 more zeros. And that's 8,000 grams. Got it? And you're moving the decimal to the right because you're going to the right side of the table. Everybody understand that? Yes? Okay, so let's go ahead and do the next one, which is 9.1 kiloliter to liter. So here we have from kilo to here, to liter. So we're gonna move the decimal 3 places. So it's gonna be 9100 because you have 1, 2, 3. Everybody see that?
Yes.
Okay, so just moving the decimal, nothing else. Now the next one is gram to milligram. So we have, let me delete this. So we're doing from gram, the base one, to milligram. So you're going 1, 2, 3 steps. And you're moving it to the right because you're going to the right on this table. So it's gonna be, the point is gonna be after 8. So it's just gonna be 98 milligrams, okay? Now here, notice that from, this is what I want you to pay attention. In this table, see this is milli is -3, micro is -6. So from here to here, you have 3 steps. The same way from kilo. Oh, come on, I'm trying to highlight this. And mega. So you have kilo is 10 to the 6. Not working. Okay, any questions? So for number 9, we have 9.1 milliliter to liter. So we're going from milli to the base unit. So what that means, looking at my table, we have milli. So we're doing from milli this way. So we are moving to the left, and that's 3 steps to the left. So that means I'm gonna move the decimal 3 places to the left. And this is what I have. So I have 9.1, moving it 3 places to the left. It's gonna go 0.0091. Okay? The next one is kilometer to millimeter. Kilo to milli. Again, let's look at the table. Kilo to milli. So we have from kilo all the way to milli. So I'm moving to the right, and you're moving 1, 2, 3, 4, 5, 6 steps, right? 6 steps to the right. So let's go ahead and move the decimal. So we have 6 steps. So I have 7, 2. So these are two. How many I said? 7 or 6 steps?
I think you said 7.
I'm sorry?
I think you said 7.
1,
but
2, 3, 4, 5, 6 steps.
Yeah.
6. Okay. So these are 6 steps. So I have 1, 2, 3, 4, 5, 6. You fill it up with zeros. See, 7 and 2, 0.72, that's 2 places. And then 4 more zeros make it 6, right? So that's going to be 72,000 millimeters. Okay? So what you're doing with the metrics, you just have, when you do the conversions, you just have to move the decimal to the left or to the right, depends what you're doing. The next one is kilogram to milligram. So it's going to be the same like the previous one. See, from kilo to milli is the same here, but instead of meter, you have grams. So I still going to move 3 places, right? 6 places, sorry. So I have 0.568. So I'm going to do 5, 6, 8. That's 3 places and 3 more zeros. So that's how many milligrams it is. So 0.568 kilograms, it's 568,000 milligrams. Okay. Now here, the next one is gram to microgram. So microgram was 6 places away from the unit. Let me show you that. It's also 6 places. Let me erase this. And you're going to count from gram to microgram. So from here, from the unit, you're going to go see -6. So it's 6 places to the left. Because from milli to micro, there are 3 places. And here you have 3 more, so it's 6. So I have to move it 6 places. So from gram, so you're moving it 6 places to the right side. So it's going to be 9, 8. So that's 3 places because the decimal is here. So I have 1, 2, 3, and 3 more zeros. So it's going to be 98,000. Okay, everybody understanding this? And then the next one is the same way, milli to micro. Milli to micro was 3 places away. Let me show you, milli to micro. See, this is the one. It's in 1, but see, this is -3, this is -6. That tells me they're 3 steps away, okay? There are also another units between them, but we're not using them. That's why we're using only power -3 and then power -6. So this, so here we're gonna move the decimal 3 places from milli to micro. So milligrams to micrograms, I'm gonna, so I have 2,000. And I have to move it through the 3 more places. So it's here, and I have to do 3 more zeros, right? So it's gonna be actually 2 million micrograms. Okay? Everybody get that? Now, when you do square, when you do cubic unit, you have to do it 2 times or 3 times, okay? So what that means, from meter to centimeter, let's see how many steps you have. So from meter to centimeter, right? How many steps?
2.
That's 2, okay? So these are 2 steps. So instead of doing 2, you're gonna do 4 steps. Because it's a square, you have to do it 2 times, okay? So keep that in mind. If it's square unit or cube, if it's cubic, you're gonna do it 3 times, okay? So here we have centimeter is 2 places away from the original. So we're gonna move it. Oops, we're gonna put 2 zeros, right? So this is how many centimeter is gonna be, but you have to put 2 more zeros because it's a square. Everybody understand that? So put in 2 zeros for meter to centimeter, and 1 more time 2 zeros because we have square. And that's gonna give me 40,000. Okay? Everybody get that?
Yes, ma'am.
So the same way with hexameter, cubic hexameter to cubic centimeter. So let's see how many steps away it's hecto to centi. Hexa is here, and this is centimeter, right? So we have 1, 2, 3, 4 steps away. 1, 2, 3, 4 steps away. So it's 4 steps to the right. So that means you're gonna move it 4 places to the right. There's gonna be 1, 2, 3, 4 here. And then 2 more times. So 4 places. And then, sorry, what's happened? Okay, so 2, and then I'm gonna put 4 more places. So this is another 4 places. Everybody see that? And then 4 more zeros. So this is how you move it 3 places. So technically it's gonna be 250 millions. Okay? Everybody understanding that? Because it's cubic centimeter, you have to do it 3 times. Okay, next one is about, we have to convert to square meter to square kilometer. Okay, now billion, how many zeros have billions? Million has 6. How many zeros is 1 billion? Do you know?
6.
6 is a million. A billion has
And 9.
9. That's right. So it's gonna be 130, and then you need, I'm gonna put 4. So 3, 3. We have 3, 6, and 3 more. So this is 130 billion 400 millions. Okay, and this is square meters. Okay, and you have to convert this to kilometers. Square kilometers, right? So let's look at the table. So you're going from meter to kilometer. So we're going to the left. How many steps? Let's see. From meter to kilometer. How many steps to the left? 1, 2, 3 steps to the left. Yes? meter to kilo. So we're doing 3 steps to the left. That means you're going to move the decimal 3 places to the left once and 3 more to the left because it's a square. So the decimal is going to be right in here, right? So I'm going to get 130,400 kilometers square. Everybody understand that? No, because it's a square, you're going to do it 2 times.
Mm.
Okay? Everybody understand that?
Yes, ma'am.
Okay, then we're going to have another one. Let's go ahead and do. So this is the preview for Imperial system conversions. So when you do conversions, you're going to multiply by the unit conversion in the way so you cancel the old unit and you get to the new unit. So this is how you do it. You have, for example, if you want to change 12 inches or 3 feet. Here the example you have 3 feet, you want to change it to inches. So you're multiplying the unit conversion between feet and inch is this one. You know that 1 foot is 12 inches, right? Now we need to multiply by feet down because you want to cancel the feet. See, up and down, they're going to cancel and you're going to be left with inches. So that's why you're multiplying by whatever is the old unit in the bottom and the new unit is going to be in the top. So sometimes you can multiply by 12 over 1. Sometimes you multiply by 1 over 12. So this is like the ratio between the inch and the feet. Okay, so I'm going to write it like in general. So if I have old unit and I want to change it to something else, I'm multiplying by a fraction. I need to put the old unit down and the new one up, because that way you cancel the old one and the answer is going to be left with the new unit. Make sense?
Yes.
Okay, so that's how you do this type of conversions. You have to know the unit conversion and then you change it that way. Okay, so here we have a question, how many minutes in 24 hours? So I'm going to start with 24 hours and you want to change it to minutes, right? So these 24 hours, I need to change it hours in the bottom. I need to know 1 hour, how many minutes we have, right? So how many minutes in 1 hour?
60.
60 minutes. So this is the ratio you're going to use. You're going to use 60 minutes is 1 hour. And then remember, the hour have to be in the bottom so it can cancel. And then after you cancel the unit, my answer is going to be in minutes. But now the 24 is in the top. It's technically 24 over 1. So now you technically multiplying the numbers straight across, right? You multiply the 2 top numbers and multiply the 2 bottom numbers, which are 1 and 1. So it's going to be a whole number. So technically here, for this example, you just have to multiply 24 times 60. And that's
1,440.
That's right, 440 minutes. Okay? Everybody understanding this? Okay, the next one we have this area here. 5 feet and 6 feet. That's the area. If you want to calculate the area, it's going to be 30 square feet, right? Now 30 square feet, you're going to change it to inches. So you change the 5 feet to inches, you change the 6 feet to inches, and then you multiply them and you get the inches square. Everybody understanding that? Yes? Here we have the same idea with the volume. If you have a cube of 2 feet, 2 feet each side, the volume is going to be 2 times 2 times 2 is going to be 8 feet square. I'm sorry, cubic feet. Okay. Now, how are you going to change that to inches? So let's do that. We have to do that. So we're going to start with changing the 2 feet. You're going to change it to inches first, right? So we know 1 foot is what? 12 inches, right? See, feet and feet cancel. So I have 24 inches. So what that means? We're gonna multiply 24 times 24 times 24. And that's gonna give me the volume in inches. So when I multiply those 24 times 24 times 24 inches, let's see, I got 13,000. Is that what you get?
Yeah, 13,824.
24 cubic inches. Okay, that's right. So any questions here?
Why did you set it up like that? That's the only thing I'm confused about.
Which
Is
one?
the 2 feet and then the 12 over the 1. Like, why is it set up that way?
Yes, because you want to cancel feet and feet. Okay, because you want to cancel the old unit, and you know that 1 feet is 12 inches. So you change it, see the way you did it over here the same way. Instead of 6 feet, you have 2 feet. You multiply by 12 inches and 1 foot in the bottom, because you always want to cancel the feet, and the feet are going to cancel. And the answer is going to be in inches. So right here, you cancel the foot, and that is left with inches. You multiply 6 times 12 is 72 inches. Okay?
Okay, thank you.
You're welcome. So that's how you do that. That's how you multiply. That's how you change. So we're changing 2 feet at 24 inches. And then when I multiply, let me do it one more time. 24 times 24 is 576, and then multiply by 24 again is 13,824. Yeah, that's right. Okay. Any questions? Okay, let me show you how to do this in another way. So let's say you don't want to change, the 2 feet first 2 inches. You just want to change the volume, which is 8 cubic feet. Okay, so if I want to change this, I'm going to multiply by, I'm changing feet in the bottom, inch in the top, right? And I know that 1 foot is 12 inches the same way. But see, now I cannot cancel it because this is cubic feet. This is just 1 feet. So what I need to do, I need to cube this. Okay? So when I cube this, I'm going to have 8 cubic feet multiplied by 12, 12, 12, 3 times. So when I multiply, what is that? 12 times 12 times 12. It's 1,000. Hold on, let's do it again. 12 times 12. 144 times 12 is 1,000. Yeah, that's right. 728 is going to be inches square. And then in the bottom, when I multiply 1, 1, 1, 3 times is 1. And the feet, I'm sorry, cube, not square. Because you're multiplying 3 times. And this is going to be feet, cubic feet. Now, because it's cubic feet, I can cancel cubic feet, cubic feet. And now I have to multiply 8 times 1,728 when I multiply it by 8. is going to give me the same answer. Okay? So everybody understand that? So you can do it both ways. Oh, is that word stop working again? Oh my goodness. Okay, I got the same answer, but I can't write again, so I have to reload again the page. Okay, so this is how you can do it in two different ways. Everybody understanding this? So you're gonna get the same answer if you change the side and then you multiply the answer 3 times by itself, or if you find the volume using the given fit, the given unit, but then when you change it to the new unit, you have to cube or square the one you have before. Okay, make sense? Okay, so here in this page, we have page 37. We have some Imperial conversions we're gonna use. You have inch to centimeter, foot to inches, and all this for length. You have the area conversions, you have volume conversions, and mass and weight. So I kind of screenshot that. I make it like a little screenshot. So I'm gonna use this when you solve the problems. So there is another page also after a few pages with the conversions. So you can use it like a formula sheet. You don't have to memorize all these conversions, but you can use them. And that's why I have it here in my site of like a screenshot. So we're going to use these conversions. And always when you do conversions from system to system, doesn't matter. Always if you have alt unit, you're going to multiply by the ratio between the new and the alt. And you always put alt in the bottom because you want to cancel the alt. And you're going to put the new in the top. And the answer is going to be with the new unit you're looking for. It doesn't matter which one of those you're using, okay? So let's just take example and follow that rule. We did this table already. So let's start with number 3. Now you can read number 1 is really interesting information. And let's start with number 3. You have the packet, you can read it later. So number 3, we have to convert 72 inches to yards without using calculator, which means just write the way you write it. So we have 72 inches and I need to go to yards. So I'm going to put inches in the bottom and yards in the top. So I'm going to look at my formulas here and weighs inch to yard. I have inch to foot and feet to yard, right? So I can do that. I can start, it's over here. Everybody see that? So 1 yard is 3 feet. So that means instead of going right away to yard, I need to go through feet. So I'm going to change inch to feet first. So I'm going to go from inch to foot. 1 foot is 12 inches, right? So now I'm going to cancel the inches and my answer is going to be with feet. And then from here, I'm going to multiply one more time by the feet in the bottom and I'm going to use yard. So what I know about foot and yard, I know that 1 yard is 3 feet. So I'm going to put 1 yard is 3 feet, right? So everybody understand what's happened? You cancel the feet, and my answer is gonna be with yards, okay? So sometimes you don't have direct conversion. What you need to do, you need to go from unit to unit to get, you can go a few times to get to the unit you wanna get, okay? So here we start with inches, and then you go from inches to foot, you know, 1 foot is 12 inches. And then from feet, you go to yard because 1 yard is 3 feet. Everybody understand that so far?
Yes.
And then from here, we have to, the answer is going to be in yard because inches cancel, feet cancel. The answer is going to be in yard. Now, what I'm doing with the number 72 is over 1. because the 12 is in the bottom, that means I'm going to divide. So I'm going to divide 72 divided by 12 is going to be 6. And then this 3 is in the bottom also, so I'm going to divide 6 by 3 is going to give me 2 yards. And this is my answer. So 72 inches are 2 yards. You got it?
Why did you divide it?
Because the numbers up, you multiply, the numbers in the bottom, you divide them. You divide by. Like when you have fraction, 5 or 6 over 2, what 6 over 2 means? 6 divided by 2, because fraction means division, right? So you have 72 divided by, if you want, you can multiply all the numbers in the top. So it's 72. And you multiply all the numbers in the bottom, which is 12 times 3 is 36. So 72 divided by 36 is 2. You can do it that way also.
Okay, that makes
Okay.
sense. Thank you.
Yeah. Okay, everybody good? So now let's go ahead and do the next one. So the next one we have is 21.5 inches, and I have to go to centimeters. So let's see what is the conversion between inch and centimeter. So I know 1 inch is 2.54 centimeter, right? So here I'm gonna multiply inch in the bottom because I want to cancel the inch, and centimeter in the top. Okay, and here we have the conversion. 1 inch is 2.54. So first you decide which one is going to go up, which one is going to go down, and then you get the numbers from the conversions table. And then here, what you're doing with the numbers? My answer is going to be centimeter, obviously, because the inches cancel up and down. So now I have 21.5 over 1. So technically, I have to multiply 21.5. I have to multiply by 2.54. Everybody understand that?
Yes, ma'am.
And I'm going to get 54.61.
0.61.
Thank you.
Mhm.
Okay, got it? Okay, let's do 120 meter to yard. So let's see what is the relationship between meter and yard. Where is that? Yard and meter. Yard. We don't have exactly yard to meter, right? But we can go, oops, sorry. We have meter to yard. Okay, let's do this. So meter yard is going to be in the length here, right? So we can do different things here. You can go from meter. We can go to inch. Or you can go to centimeter. And then from there, we can, so meter, you're going to centimeter. And then centimeter to inch. And inch to yard. You can do that. Okay? So let's do that. So meter, we're going to go to centimeter. Do you remember that? Centimeter is going to be 2 units. So it's going to be 2 steps. Let me show you. I guess I need this table also. Where was that? Page 30, 34. Okay, 34. See, meter to centimeter. it's 2 steps down, right? So that means you're moving the two places, 2 more places. Okay? So that's 34. And we're in 37, I think, or 38. 38. Okay, 38. We're in 38. So 120 meter to feet. So what is meter to feet? Do you have meter? 1 meter is how many feet? We don't have it here. Yeah, obviously it's going to be easier that way, but we don't have meter to feet. Oh, we have it. Sorry. Yes, 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 we have it. Yes, that will be easier. Thank you. So we can go to meter to feet. You have it here. I didn't see that. Sorry. Thank you. So you have 1 foot is, good job. Yes, 1 foot is 0.3048 meters. So that's what you're going to use. So I have meter and foot. So I'm going to be multiplying here. Meter in the bottom, because you're going to cancel the meter, and feet in the top. Okay? So it's 1 foot is, let me look at the number again, 0.3048. Okay? So right now we have foot, and you want to go foot to yard. You want to go foot to yard. So we have 1 yard is 3 feet, right? So we're going to multiply feet down, yard up. 1 yard is 3 feet. And then feet cancel. So now what's happened here? We're going to divide 120 divided by 0.3048. And then the number I get, I'm going to divide by 3. So it's going to be 131.23. I'm just going to put 131 yards. I'm going to round to the whole number. Okay? Everybody understand that? So when you do the unit conversions like that, you have to look at the formulas, the tables, the conversion tables, and you have to see where you're going to go through to get to the unit you need to. Okay? Okay, so the next one we have, let's do the squares first. I'm going to skip mile, or let's do 55 miles to meters. So miles, we have mile to kilometer, and then kilometer, you're going to change it to meter. Okay? So we have 1 mile is 1.6 kilometer. That's what you're going to use. So I'm multiplying. I'm not going to use all the decimals. So I'm multiplying miles in the bottom, kilometer in the top. So I have 1 mile is 1.6 kilometers, right? So what that means, right now I have my answer in kilometers, and kilo to meter, I need to move it, that was in page 34, kilo, I need to move it to 3 places. See, from kilo to meter, I need to move it 3 places. Okay, so let's do that. Okay, so in page 38, so we have, when I multiply 55 times 1.6, it's going to be 88. And then I need to move it 3 places to the right. So I need to put just 3 zeros. Because kilometer to meter, you're moving it 3 places to the right. Everybody understand that?
Yes.
So it's going to be 88,000 meters. Okay, then let's do number 7. We have inches square to centimeter square. So here we're going to multiply by inch to centimeter, which is 1 inch is 2.54. But you have to square the units. So 1 inch, 2.54 centimeters. And I have to square every chin. So you can cancel the inches square. So what you need to do here is you need to square 2.54. So I have 2.54 times 2.54. That's 6 point something. And I'm multiplying by 1.25. So it's going to be 8.0645. I'm going to put 8.1. I'm going to round 8.1 square centimeter. Okay? Everybody get that? Any questions? So that's how you do the conversions for the length. Then the rest of it pretty much doing the same. All of those is doing the same. Okay? Now the applications is the one you're going to do next time. So let's just do a few more. And so let's go ahead and do acres to square feet. So acres to square feet is right here. This is what the conversion we're going to use. 1 acre is 43,560 square feet. So I'm going to multiply acres in the bottom and square feet in the top. So 1 acre was 43,560. Okay, so when I multiply 43,560, when I multiply by 1.07 acres, because I have to multiply the two numbers because acres cancel, and the answer is in square feet. So I'm multiplying because this number 1.07 is in the top. I multiply by 43,560 and I get 46,609.2 square feet. Okay, so that's what I get when I change acres to square feet. Now let's do number 9, gallon to ounces. So here we have gallon to ounces, fluid ounces. How are you going to change that? You're going to look at the volume now, right? So gallon, you have to go from gallon to what?
You can go from gallons to liters and to fluid ounces.
Gallon to liters, and then liter to fluid ounces. There you go. That's right. Good job.